Welcome back to Maths with Mrs. J. We've reached the point in our unit circle where we're going to talk about some exact values. Remember that our sine, cos and tan ratios do still work in any right-angled triangle, and we're going to use some special right-angled triangles to help us get some special exact values. In maths, we like to have the exact value for something if we possibly can. Quite often in trig, you might have something like √3 or 1 on √2 as the exact answer. And if you give a calculator version, all that will be an approximation. You need to realise that. If you want the exact value, you will normally have to use surds. Now, the three angles that we're concerned with here are 30 degrees, which in radians is pi on 6, 45 degrees, which in radians is pi on 4, and 60 degrees, which is pi on 3. We're going to look at the 45 degrees first. And I've drawn a triangle here. It never hurts to remember what triangles you use to get these, just in case you do forget them. So we're using a right-angled triangle. It's isosceles, and each of these side lengths is 1. Using Pythagoras' theorem, we know that the square on the hypotenuse is the sum of the squares on the other two sides. 1 squared plus 1 squared is 2. So that this length here is going to be square root of 2. We also know that because this is isosceles, this angle here and this angle here will both be the same. And because that's 90, and both of them are the same, they're both going to be 45 degrees. So it doesn't matter which one you're looking at. We might just look at this one. So looking at this particular triangle, sine of our 45 degrees is our opposite on our hypotenuse. Now, some people leave it like that. Some people like to rationalise the denominator and write it as √2 on 2. It depends what you want to do, but either of those is actually correct. Cos of 45 degrees is adjacent on hypotenuse, which is the same thing. And tan is opposite on adjacent, which is just 1. So tan of 45 degrees is 1. Let's write in these values here. We'll use the rationalised denominator version. All right, now if we're interested in finding out about angles 30 degrees and 60 degrees, what we do here is we take an equilateral triangle that has 2 as its side length, which means that each of these angles will be 60. And this angle up here will also be 60. But we drop a perpendicular, which will halve this side length. So this will now be the same as that, and it will also halve this angle into 30 and 30. So now what we're using is this triangle. Let me just redraw that here. So you've got a triangle that's 2 and 1, and you've got a right angle here, and let's just fiddle with this for a minute. So this is your 60 degrees, this is your 30 degrees, this is 2, this is 1 because we've divided this length into 2 halves. What's this length going to be? Well, 2 squared is this squared, the height squared plus 1 squared. So 2 squared is 3 plus 1, isn't it? So this length here will be √3. And we use this triangle to get our values for our 30 degree angle and for our 60 degree angle. For our 30 degree angle, sine. All right, so we're thinking about this angle at the moment. Sine is opposite over hypotenuse. which is a half. Just saying that again. So we're thinking about, this is our theta in this case at the moment, our 30 degrees, opposite on hypotenuse is 1/2. Adjacent on hypotenuse is √3/2. And our tan of theta is our opposite over our adjacent. Now you can either leave it as 1/√3 or you can rationalise it to √3/3. It's up to you how you want to go there. I might leave it with a rational denominator. Now to get our 60-degree values, we're thinking about it from this perspective. So this is now our theta. Sine is opposite on hypotenuse. Cos is adjacent on hypotenuse. And tan is opposite on adjacent. √3/1 is just √3. Now, the cool thing about this is that for 45 degrees, sine and cos are the same and tan is 1. That's quite easy to remember. You should also remember that because 30 degrees and 60 degrees are complementary angles that add up to 90 degrees, sine of one of them will be cos of the other. We also found that with our, what I referred to as the vertical reference in our previous videos. So sine of 30 will be the same as cos of 60. Sine of 60 will be the same as cos of 30. And the tan is quite easy to remember as well. It's 1/√3, then 1, then √3. If you ever get stuck, just redraw your little triangles and you should be fine. In the next video, we're actually going to use these exact values to start thinking about how we would give exact values for things like sine of 7 pi/6.